Testing, testing, testing. Hey, everybody. It's, you know, I start this at 2 hours UTC, right? I start this at 2 hours UTC and at 1:58, right? 1:58 UTC. Look, I have one neighbor. I have one neighbor, good neighbor, right? Good neighbor. And at 1:58 UTC, he knocks on my door and it's like, oi, oi. So, okay, here we are. Here we are. It is 2:02 UTC. And if you don't know what you've stumbled upon a live stream, a daily live stream called Astronomy Daily Live. You can call me Cosmic, and I am here to provide a platform to share a passion. I sort of, view this as getting together on a virtual porch every single day, and we pull up our um, comfortable chairs, grab our um, beverages or other consumables of choice. And we sit around and just talk astronomy for an hour or so, sometimes a little bit less, sometimes a little bit more. I do respect your time, so I try to keep it, reasonable. But, you know, if you're like me, um, you have this passion, and it doesn't abide by the time of day or the length uh, to which you think about it. But I'm trying to be respectful, and I know that you also have choices in terms of what you view, and I think it's great. This is the wild west of sort of the new TV, right? And I think it's awesome. I love the wild west. I think it's great, and I greatly appreciate YouTube and Google for providing this kind of a platform. And actually, why don't I sort of start there, sort of a non-astronomical thing. I've uh, um, uh, just become aware of certain YouTube channels being pulled down, being penalized, being blocked, being this, being thatted, and I'm not sure about that. Cheers. I've got the coffee. I've got the hydrogen hydroxide, HOH, tonight. Cheers. Mm, fresh, fresh batch of HOH. It's great. And one of the things that I posted up on my Discord channel, and I'm going to, let's see, I'm going to share my screen here. Then this I'm just going to cover really briefly because this is not astronomical, and we're here for astro talk, not YouTube talk, right? But let me pull over my Discord channel, my Discord server, I should say. The server itself has different channels. I guess that's the right terminology to use. I'm not much of a terminology guy anyway. Whatever it is, it is. But I was just sort of interested in looking at the at the mission of YouTube. What does YouTube say that they are wanting to do, right? And so what I'm going to do is I don't remember where I put it. I put it under miscellaneous. Is it under the miscellaneous? I don't know where I put things. Yeah, there it is. Okay. So I just wanted to read through these. Okay. So this is youtube.com, right? youtube.com, way up here at the top. Oh, you know what? I'm going to I haven't tweeted. I don't think I'm going to tweet tonight. What I wanted to do was I wanted to pull up the chat. I lost my YouTube channel for some reason. Well, I'll just make a new screen and pull it up here. Let's see, YouTube. Because I want to be able to see the chat, and I also want to be able to see my live stream on my smartphone. Let's see. So we do that, and then come on. Oh, I was being a little bit slow. A little bit slow. Thanks everybody for coming in and hanging with me. Hey there, Gilles. I recognize Learn Windows 10 and computers. Hope everything is well up there in the cold white north. Bobby, hey. Nice to see you again. Glad you could stop into the, this is a circle of friends that just get together and, talk astronomy. I am not a communicator. I'm not an educator. That's not why I'm doing this. Now, I will communicate, and I probably will um, um, educate, but I hope to be educated as well. So yeah, I just love this stuff. So that's why I'm I'm doing it. I'm sharing the passion, spreading the passion around. So yeah, wow, 72 Fahrenheit, way up there. Wow, that's amazing. So yeah, we're I'm down in southeastern Arizona, and it's a little unusually warm. I think we're getting into the mid 80s Fahrenheit here where I am, but I'm pretty high up too. I'm about 4,500 feet, so pretty high, and it is the desert, which doesn't necessarily mean it's hot. It's just that it's dry. Anyway, so I was just I was sort of curious to see what YouTube says that its mission is, right? And so here it is, right at the top, right? Our mission is to give everyone a voice and show them the world. So that's pretty awesome. That's a very uh, a, a very awesome and interesting mission statement. And then they sort of expand on that a little bit. They say that we believe that everyone deserves to have a voice and that the world is a better place when we listen, share, and build community through our stories. Okay. So get down. No, I'm totally on the ground. I'm totally on the ground. It's just yeah, it's high desert. High desert. Our values are based on 4 essential freedoms that define who we are. Okay, here they are, right? So these are the things that they value. Freedom of expression. We believe people should be able to speak freely, share opinions, foster open dialogue, and that creative freedom leads to new voices, formats, and possibilities. Ooh, I'm gonna stop my and you know Gilles, you may be able to answer this. I've got a Linux machine, Fedora 24. Okay, and when I run um, a live stream, it's only with the live streams. When I run a live stream, it freezes my machine. It totally freezes my machine. It runs for a little while, but then it just gets, completely bogged down to the point that I have to do a hard reset, right? I've got to hold the power button, and it's just insanity. So if you could offer any insight into that, either now or later, that'd be great. Um, okay, freedom of information. We believe everyone should have easy, open access to information, and that video is a powerful force for um, um, education, building understanding, and documenting world events big and small. Freedom of opportunity, that's number 3. We believe everyone should have a chance to be discovered, build a business, and succeed on their own terms, and that people, not gatekeepers, decide what's popular. And number 4, freedom to belong. We believe everyone should be able to find communities of support, break down barriers, transcend borders, and come together around shared interests and passions. So, yeah, I just, I was just interested in sort of seeing what YouTube sort of thought their purpose in all of this is, and yeah, that makes it pretty clear. I think that's very very cool. I think that's kind of interesting, right? All right, well, cool. Enough about that. Let's see. Hey there, Uncle Bill. Let's see. Well, yeah, I'm using a laptop running Windows 7 with Chrome to actually stream. I'm just using Google Hangouts for that. I've got a separate Linux machine, which is sort of my work machine. I'm a research scientist, so I mean I'm actually doing you know real astronomical work, and so my Linux machine is that. But I like to watch the chat on it, and um, as I said, it when I run live streams on it, when I watch live streams on it, it just freezes my machine up totally. Frustrating. Um, let's see. All right. Well, cool. I think I just wanted to sort of show those off for no particular reason, just a piece of information. Sort of trying to understand where YouTube is coming from in terms of what are they doing, right? What are they doing? So, all right, here we are back. Cheers. Yeah. Uncle Bill, you have a soapbox? No, no, I don't believe it. See, my thing here is that this is a casual, fun get together. I do have a goal, and that is I want to find my core group. I don't think that everyone should be interested in science and that everyone should know all these things and everyone I don't think that me as a scientist should be ramming all this stuff down everybody's throats. I want to find the people who already like it, or you know hear about it and it rings a little bell in the back of their head, right? Draws them in. So if somebody doesn't care about this stuff, good, that's fine. They probably care about lots and lots of things, right? It's um, um, just not astronomy. And that's cool. You know, my attitude is that if you're having fun, um, then do it. That's all that there is. So, you know, this is just my fun. So, cheers, coffee. Yeah, cheers. But I would like to find my core group, and I don't know how big that is, and I'm not too worried about it. I think you know, as I've said many times, um, you know, there are three elements of success, and uh, 90, I would say 95% of that is being at the right place at the right time. That's that, and that's luck, right? That's all it is luck, right? But the third element, which is the third leg, right? You got to have three points in order to stand, right? It's that third leg that makes it all work, and that is you have to be prepared. So you have to be lucky, and when that opportunity comes, you have to be ready for it. So, what this is, as far as I'm concerned here, this is practice, right? I'm getting better and better and better. My goal is to get better and better and better at this, you know, having a conversation, uh, um, uh, you know, talking about things, showing you folks stuff, and sharing the passion. Speaking of passion, tomorrow, tomorrow, and I'm not exactly sure when. Hmm, I'm not exactly sure when, but sometime tomorrow, Gaia is going to be releasing their second um, data set, or their second release. They, I, I, I actually have been using Gaia data um, for my photometric and astrometric uh, work with my scope and CCD back here. And maybe a week and a half ago or so, the Gaia archive site closed down. You couldn't access any Gaia data. And I'm like, oh man, you know, I really need that right now. And so I had to go to an alternative site um, to get my Gaia data, you know, just a mirror site, right? But it's like, you know, oh man, I've got to wait till the 25th. Arr, arr. But anyway, tomorrow is the big day, and so they're going to be releasing their new set of data, and I think, did I post something on the Discord server about that? I think I did. I think I did. Yeah. Oh no, not actually about the data release itself. I guess I just wanted to make you all aware of that. Gaia is, well. Let's take a look. Let's just take a quick look at what Gaia is. I don't think I've ever actually looked to see what Gaia is doing. So let's go find out. Let's go find out. Da-dun, da-dun, da-dun. Yeah, you know, I totally agree, Jill. I mean, it's just, you know, my goal really isn't to grow. I think that'll happen um, as sort of a side effect. My thing is just share the passion, right? Share the passion. Let's see, Gaia spacecraft. It is a spacecraft. It's a little spacecraft out in orbit, measuring the positions and distances of stars with unprecedented precision. Um, let's see. The spacecraft will monitor each of its target objects about 70 times over a period of 5 years to study the precise um, position and motion of each target. So let's just see. So objectives. I want to see what the uh, the actual spacecraft is here though. Okay, so Gaia was launched in 2013. So it, let's see, it measures. Trying to see here after launch. Okay, so it's at the L2 point, which is on the other side of the Earth from the sun, right? Yeah, very stable gravitational and thermal environment. Lasigidu, oh, however you pronounce that. And then it's got a sunshade as well. So let's see. Yeah, and it basically has 3 instruments, right? It measures the positions of targets, it measures the brightnesses of targets, and it measures the radial velocity, and that is, how fast those targets are moving either towards us or away from us. Yeah. And that's it. That's it. I'm trying to understand how big of a telescope it is, though. Like there's 2 telescopes. Oh, I don't know. Okay, so the 2 key telescope properties are a 1.45 by 0.5 meter primary mirror for each telescope. How many telescopes are there? I don't know. Maybe there's 2 telescopes. Yeah, maybe there's 2. I guess I'm going to have to dive into this a little bit more. Cool thing is that, it sees a lot of stars, right? From magnitude 5.7 down to magnitude 20, right? And astronomical magnitudes are backwards, right? So the smaller the number, the brighter the target. So a 5.7 magnitude star is considerably brighter than a 20th magnitude star. Every 1 magnitude is a factor of 2.5. 5.7 to 20. Okay, cool. So yeah, it's a spacecraft that is able to look at the sky all the time. And let's see, the overall data volume that'll be retrieved from the spacecraft during its five-year mission is approximately 60 terabytes, amounting to about 200 terabytes of usable uncompressed data. So yeah, a substantial chunk. Yeah, you can sort of see this diagram here of where L2 is, right? Here's the sun, here's the Earth, here's L2 over here, right? There's L1, L2, L3, L4, and L5. Let's see. Yeah, so the data release, as I said, that's going to be happening tomorrow. So that'll be very, very cool. You know what I th- I think what that mainly is gonna comprise is just more data, right? It's just more. That's what it's all about. More. The other thing I guess I might as well share while I'm over here is I found this Gaia alert uh, thing, which is kind of cool. Haven't really had a chance to look at this uh, very closely, but and in fact, let's just hit the about. See, this live stream isn't necessarily about me telling you things and being the you know, the high priest who has all the answers. I'm on a discovery mission, just like you are, and so we're just doing this together. Let's see. So let's do an about and see what. This doesn't say anything about what it actually is. It's just about the people. Okay. It's some kind of you know, observations have been made and something, I guess, you know, unusual or strange has been observed, and so it becomes an alert. It's in a thing, you know, it's a kind of a thing where it's like, well, you know, let's go look and see what this is. Mm-hmm. Let's see. This just happened a couple of days ago, right on April 21st at 17:48:13 UTC. So let's just dive into this here and see. I'm not quite sure what TNS stands for, erg, but yeah, let's just do this and see where it leads us. Just follow our noses here a little bit and see. So alert date, Julian date, alerting magnitude, historic magnitude. Why can't I scroll? Come on, scroll. I don't know what it's doing. Ah, whoops. Oh, I see. It was loading a picture of some sort. Um, class unknown. Other survey detections, none. Comments. Okay, so blue Gaia source brightens by 0.2 magnitudes. Yeah, so yeah, here's sort of the apparent magnitude of this target over time. And for some reason, this last observation, see how it got a little bit brighter there? I guess nobody knows why. So, it's, and that's an alert, right? So, you know, maybe something interesting um, is happening there. Don't know. Kind of cool though. Display the corresponding spectrum. Wow. So you can look at individual. So they're looking at spectra here, I guess. Yeah, I'm gonna have to dive into this a little bit to really understand what I'm seeing. So transient name server makes sense. Okay, so these are just spectra. All right, pretty cool. Let's look at what follow-up says. Did it do anything? Follow-up not available. All right. So let's go back to the alerts index and let's look for another one. I thought I saw one that was talking about a supernova. I I was lucky enough back in 1991. I was doing some photometric work up at the 61-inch telescope up on Mount Bigelow, north of Tucson. And every single time I had an observing run, which was usually a few nights every month or so. I would go at the time. The internet really wasn't up and running yet, right? This was 1991. I mean, it was there, but it wasn't like it is now. Um, and so I had to go over to the library and look up the the IAU, the International Astronomical Union circulars. And those are still published, and those are just things that are new, that um, have been observed in the sky. And so this is the same kind of a thing. And one of those was a supernova. So I actually saw with my own eyes, not with a CCD camera, not with anything else. I saw supernova 1991T, as in Tom, and that was very very cool. I So I can say that I have seen with my own eyes a supernova, an exploding star. So it was very very cool to see that. Very very cool. It just looked like a faint star, but that's exactly what it's supposed to look like. So here's one here. Here's a confirmed supernova 1b near this galaxy. So let's just take a look at that. And of course, this isn't this image here isn't isn't the Gaia image. This is probably like a digital sky survey image, but you can see that there is a galaxy there. Whoop, right? Faint galaxy, and yeah, it's just going along, going along, going along, and all of a sudden, look, there's a bright spot right there. Now it's 17th magnitude, which is still pretty faint, pretty faint. But the fact that they've detected that and it looks like it's confirmed, that's pretty cool. That's very very cool. Looks like there's a spectrum there as well, a couple of spectra too. That's pretty awesome. Let's see if there's any follow up on this. This one, nope, no follow up there. Anyway, so this is just another resource. It is so awesome, right? That we can sit here uh, at our desks. I'm in my socks, just very very casually, and have access to this data. This is awesome. This is very 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 awesome. Um, yeah, Gaia, I believe, is looking at the entire sky. It's looking at the entire sky. Ah, cheers. Hydrogen hydroxide is just awesome. So yeah, here's actually they provide a little map showing all the alerts. It's loading here. My internet is slow. Sorry. So these are all the alerts in blue, and you can sort of see here's an all sky map, right? Here's the Milky Way coming through here. Here, I'll knock all these out, right? I'll knock all these out. So here's the Milky Way. Let's see, the large and small Magellanic clouds over here, I guess. think there's an RA in DEC. Yeah, no, that's not the LMC and SMC. That must be down here. I don't know. I think we can move this around. Yeah, there they are. So here's the large and small Magellanic Clouds. And here's the, yeah, okay. You can rotate this thing around and have a lot of fun with it. But you can show the alerts from like the last 7 days, right? And then you can select each one. And I think this will center it. Will it center it? I think if I double click, it's supposed to center it, but it's not, or it's trying to. I don't know. I don't know. Maybe it's trying to, and it's just completely destroying my machine. I don't know. Will this work? Yeah, that'll work. Huh. There it goes. Well, let's try to move it. No, we can't move it. Just trying to zoom in on that one there. And we can zoom in like this. And again, these images aren't Gaia images. These are like from the Digital Sky survey, just to give an indication of where these targets are. This thing is not behaving. Here we go. Oops. This is a very, very old laptop. It is tired and sick, but it's all I've got. All right, so that's a galaxy of some sort. Let's, can we click on that? Come on. Okay, so that's Gaia 18BAA. So you can actually go over here and type in Gaia, GAIA 18BAA, and you can actually go to the alert as long as I've got it typed in right. Slow machine today. Okay, so it doesn't, I don't know what this is doing. Showing all the alerts. I don't want to show all the alerts. All right. Well, anyway, that's just it's kind of an interesting resource, right? Interesting little resource. I haven't even looked at this whole thing. Okay, there's little apps that you can do. Oh, there's a CSV file that you can grab all the alerts. That's pretty cool. There it is. All right. Well, if I wanted to, not going to. Virtual observatory alerts. Oh, there's a Twitter, Gaia alerts. Very cool. I'm going to sign up on that for sure. For sure. Very cool. Well, hey, let's do an object of the day. Now, I introduced a new form of object of the day a couple of days ago. I've been limiting object of the day to like the Messier catalog and the New General catalog, but I decided that I wanted to expand on that a little bit and include everything, including uh, including stars, right? So let's do that again. So what I'm going to do is I'm going to do that. We're going to go over to random.org. Okay, and we're going to have random.org choose for us which constellation we're going to find an object in. So there are, according to the International Astronomical Union, there are 88 constellations. So random.org is going to choose for us an integer between 1 and 88. Okay, drum roll, please. Number three. Number three. Now, I have an alphabetical list of the constellations. So at least of all 88 of them, okay? And the third one on that list is the constellation of Apus, A-P-U-S. So I'm going to stop sharing really, really quick because I just want to show you. I'm going to, let's see, which one is it going to be in? It's going to be in this one. So this is a 3-volume set called Burnham's Celestial Handbook. Now I've had this set for 40 years, almost 40 years. So this is the only one. Yeah, this is the only one that still has a cover. So this is volume 1. It goes from Andromeda through Cetus. These are organized by constellations. So there's Andromeda through Cetus. Okay. Now I'm sort of embarrassed to show you these other ones, but I'm going to anyway. Let's see. Here's volume 2. Oh, there. So you can volume 2, right? Burnham Celestial Handbook. And here's volume 3 with spilled coffee on it. No, it's you know, hey, these books are well used. These books are well used. So constellation Apus is in volume 1, right? And I don't know much about the constellation of Apus at all. So I guess what we should do first is let's go look and see where Apus is. So I'm going to share my screen again. And we're going to go back over here and we're going to go, we're going to go like this. We're going to go google.com. It's probably a southern hemisphere constellation, probably. I got to spell it right. APUS constellation. And there's Wikipedia. Wikipedia is our friend in this case because it usually has a nice map. Yeah. Oh, it's a very southern. Yeah. It's a very southern constellation. Let's see. So you can sort of see, where can we see it? Here we go. So here's the right ascension along here. You can sort of see, 15, 16 hours, 17 hours. Here's 18 hours over here. Here would be 14 hours, right? So Apus is south of Triangulum. And look, it's just south of Centaurus. Most of you have heard of Alpha Centauri. I'll bet you that's Alpha Centauri right there. So here's the constellation of Apus. And here are sort of the boundaries of that. Here's the South Pole. So yeah, it's a very, very southern constellation. And usually how the names of these stars go is that the brightest star gets designated alpha. The next brightest is beta. The next brightest is gamma. The next brightest is delta. On and on and on. all of these stars have multiple names, multiple names. All right, so I'm going to go to Burnham's Celestial Handbook, and I'm going to go to Apis. Let's see, where's Apis here? Come on, Apis. It's a little constellation. There it is. All right, Apis. So there's a bunch of binary stars. Burnham's Celestial Handbook. Maybe here I'm gonna stop sharing again so I can just sort of show you what I'm looking at here. So here's the list. Oh, my cover. Oh, my cover is coming off my book. How can that happen? So here's a list of I can't really see. Here's a list of binary stars in the constellation of Apis. I know that you can't see that all that well. And here's a list of variable stars and non-stellar objects. So here are the variable stars. Here are the non-stellar objects. Now, I'm going to pause just for a second because I have a barking doggy that just needs to be stopped. Just needs to be stopped. You know how dogs, they start to bark and they just can't stop unless they're just sort of nudged a little bit. I'm going to go nudge him. So I'll be right back in like 10 seconds. Okay, hold on. All right. So I'm looking at Apis, and this is the part that I'm not really doing randomly yet, and I need to figure out a way to do this randomly. But let's do a binary star, right? Let's do a binary star. I don't know how this is going to work. Um, you know, delta looks like it's like a double double. So it's actually two stars, and both of those stars look like they're a double. Yeah, that might be kind of interesting. So let's look at Delta Apis. So, all right, I'm going to share my screen again. Share my screen again. And I'm going to get back onto the chat here because I know that it's just frothing with yeah, books ought to be used and read, right? If they're just sitting on the shelf, I just don't see a point. I don't see a point to that. All right, so let's go to Simbad and see if we can dig out Delta. I don't know what the constellation name would be, like Api. I don't know. Let's see, Delta. Let's just do Delta Apis and see what that comes up with. Identifier not found in the database. Del APS. Let's. Sometimes you got to be a little bit determined. Delta Apis. Delta Apis. Delta Apotus. So Apotus. Apotus. Okay. Delta Apotus. That's kind of interesting. All right, let's try that over on Simbad. So Apotus. Basic search. Delta Apodus, right? Ah, poo. Nothing about Delta Apodus? Sinbad, you're letting me down. You are letting me down. Well, let's go back to Wikipedia had something about it. So let's see if there's any pointers over here. It's a double star. The brighter star, Delta 1, is an M-type red giant. Pretty bright. And then there's a Delta 2, which is a K-type, which is also quite red. Let's see. Image doesn't help much. Long term, here's a bunch of references that theoretically talk about these things. Usually I like to go to Sinbad to find all this information because, I sort of trust Sinbad a little bit more than I trust Wikipedia. uh, hmm. Let's see. Well, let's see where this brings us. It's an actual image. Well, that's okay. Oh, here we go. That's a Sinbad reference. Here we go. Here we go. Yay. All right. So yeah, it looks like what I had to do is I had to specify Delta 1 or Delta 2. Aha. Okay. Well, that's cool. Let's try this theory. Okay, let's try this theory. I'm going to go back to this. Bear with me here. As I said, this is not educational. This is not. I'm not trying to teach you anything. We're doing this together. So hang with me. So let's just do del 02 APS. Yeah, there we go. Okay. All right. So I don't know. Let's why don't we stick with yeah, why don't we stick with oh, I don't know. Let's do Delta 1. Let's do Delta 1. Delta 1 APS. I'm glad we found it. Sinbad is supposed to have everything in it. So that's why I was a little bit surprised when it didn't come up. But of course, it's just a machine, so you have to tell it exactly what you want. Exactly. So yeah, okay, let's take a look here. So here are the coordinates, right? Right ascension, 16 hours, 20 minutes, 20 seconds, and then a declination of negative 78 degrees, 41 minutes, 44 seconds. Um, it's uh, it's moving pretty quick. Proper motion here. I think this is in right ascension and declination. So it's moving. I guess that would be west and south, right? West and south, negative RA, negative dec. And that's in milliarc per year, right? So that's a very, very small amount. It's moving towards us at 12 kilometers per second, or rather, mutually we are moving towards each other at that speed. And it looks like, let's see, okay, yeah, so this is an M4 star, which is a, red, faint, cool star. You can see its different magnitudes in different filters here. So U, B, and V are sort of visible, and then J, H, and K are more towards the infrared. And as you can see, it gets really, really, really bright in the infrared. It actually goes negative here. So yeah, these are very, very red stars. Yeah. Here's a bunch of different names for exactly the same star. These are just different catalogs, right? They've said, okay, let's look at all the stars that have these kinds of characteristics, A, B, C, D, E, and we'll put them in a catalog. And so that's basically what these are, right? Just different names. It's a bunch of references, so we'll get back to that in a minute, because I definitely want to find out a little bit more about this this star, Delta 1 Delta 1 Apotis, I guess is how you would pronounce that. So here's some measurements of velocities, proper motions, parallax, and I don't know what MK means. So pretty good agreement in terms of the velocities. Looks like it's moving towards us at about 12 kilometers a second. Not too good. Well, maybe sort of good agreement in terms of proper motion. Yeah, not too bad. I think parallax. I want to say that that's a distance measurement, and I think this first one is in light years, and these other two are in parsecs, right? Because 3.26 light years is in a parsec, so 4.26 times 3.26 gives us 13.88. Yeah. So it's relatively close between 13 and 18 light years away. And I guess this is the spectral type, right? So there's pretty good agreement that it's an M, except for this last one. But wow, look at these old measurements. It's like once the measurement is made, and once the determination is made that this is an M star, it's like nobody looks at it again in that way. I don't know. I think they're saying here that maybe this is a K star as well. Who knows? A little bit of disagreement there. That's all right. Doesn't look like there's any other observations. But let's look at the references really quick. Quite a few for just a lonely old star, right? Pretty recent too. Let's see. Symbiotic giant. So maybe this star is a symbiotic giant star. A pilot deep survey of X-ray emission. Radio velocity, Gaia 100,000 proper motion project. Fundamental parameters and infrared excesses of Hipparchus stars. Hipparchus is another survey. I think Hipparchus was a is or was a satellite too, if I remember right. Early star catalogs of the southern sky: de Houtman, Kepler, and Halley. 0.6 years of Derby near infrared stellar light curves. That could be interesting. Flight calibrations, long-term photometry, and periods for 261 nearby pulsating M giants. Well, this star is definitely an M giant. Catalog of multiplicity among bright stellar systems. I'm not quite sure what that means. Photometry, 11 color system, apparent diameters, and absolute radii of stars. That could be kind of interesting. Long-term variable stars, long period variable stars. FK6 catalog, stellar radii of M giants. So the one that sort of looked most interesting to me was this one: long-term photometry and periods for 260 nearby pulsating M giants. So let's take a quick look at that. I know that we're going over time here a little bit. Go to our favorite ADS. See if there's a PDF of this. There is. See, my thing is that I don't want to read, some news story about this star, right? I want to go to the source. I want to go to the horse's mouth. I want to get the actual, scientifically valid, I want scientists' interpretation of their data, not some science writer's interpretation of the scientist's interpretation of the data, right? So I like to read the actual papers. And yeah, these papers usually are going to go way over my head, and they're going to go over the heads of most of the people who read these. But as far as I'm concerned, that's how I learn things. Is that if I'm challenged a little bit and have to figure things out. So what I do is I start with pictures, right? So let's look at the actual paper. I don't know why this is doing that. There it goes. Slow internet. Sorry, I live in the middle of nowhere. Our internet comes via smoke signal, so it just takes a little while. We present the results. I'm going to zoom in here a little bit. We present the results of a 5.5-year CCD photometric campaign that monitored 261 bright southern semi-regular variables. The data is supplemented with independent photoelectric observations of 34 of the brightest stars, including 11 that were not part of the CCD survey. Pulsation periods and amplitudes are established for 247 of these stars, so that's most of them. The majority of which have not been determined before. Very cool. I like new data. All M giants with sufficient observations for period determination are found to be variable. So that's kind of cool. Multi-periodic behavior. So they just don't have one variable period. They have several. So, it's a dynamic universe. It's an interesting place. Why make it simple if you can make it complicated? That's my attitude too. It makes it much more interesting that way. Let's see. Okay, so we're gonna dive into this a little bit here. See what they do. Let's see. Photometric surveys of M giants and large galactic bulge have revealed a rich variety of pulsational behavior. Pulsating M giants are potentially important as um, distance indicators, since there apparently seems to be a period luminosity relationship. So that just means, that depending on how luminous the star is, their variability period can change. So that's pretty cool, and that's sort of a known thing. Let's see. We constructed a wide field automated survey telescope optimized for precise photometry of bright local SRVs. SRV. What's an SRV? Semi-regular variables. Semi-regular variables. That's one of the tricks in these papers, right? If you find something like that, right? It's like, what's an SRV? Just keep going back, and they'll eventually reference that acronym. So a semi-regular variable. Sample selection. Nearby variable M giants was extracted from the Hipparcos catalog. So they, of course, had to be a spectral type M. Candidates were further to select those likely to yield high quality photometry. So they had to be, high enough up in the sky, um, bright, quite bright, right? Anything fainter than eighth magnitude, they excluded. So they were just looking at the really, really, really bright stars. I think Delta One, wasn't that? I don't remember now. Let's go back and remember at least what the visual magnitudes were. So yeah, U is pretty blue. It's almost a violet. Blue is blue. V is around like 5,500 angstrom. So that's sort of visible. So yeah, pretty bright, pretty bright. And this is a V magnitude, right? So that selection yielded 183 candidates. So very cool. Let's see, what else do they say here? Published Hipparcos. Our CCD data is supplemented by the following sources. Blah 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 blah. Okay. So there's that. The magnitudes. Okay, yeah. So this is just collecting all their data. Here's the actual survey equipment itself. Very cool. So it sort of looks like, yeah, they're actually using this telescope here to do the work. They're not using, the big scope. They're using little scope. Man, that looks just like mine. Yeah, actually, I've got a SBIG ST7ME. So this is extremely similar to mine. Here, let me. I haven't shown that camera off in a little while. Let me go do that really quick. I know that we're running over. Chill. Hold on. So here's my, you see that? It's probably going to be out of focus. Anyway, there it is. This is my SBIG ST7ME. And yes, Jill, that is a parallel port. It's a parallel port. Yeah, yes, sir. All the way with parallel. I'm going to carefully place that on the floor. All right, let's finish this paper and then we can get out of here. Share my screen again. It's pretty cool that, yeah, it looks like this is a USB. It looks like it's a USB. So, yeah. Anyway, yeah, they were just using, this refractor up here. So get a nice wide field of view. And because, they're looking at very, very bright stars, you don't need a big telescope to do that. Calibration, reducing flux, CCD observations. Yeah, I'll have to walk through these and see how their measurements compare to mine, at least what I'm seeing now. So yeah, very, very cool. Let's see. I guess I'm mostly interested in seeing their results, right? Because this is just going through how they're collecting the data, how they're reducing the data. Oh, okay, so here's some light curves for some stars. In this case, AT Puppis. Oh yeah, let's look for our star, huh? Would it be like Apodus? Nope. How about Apus? I didn't hear any dings. Delta. Oh, not seeing anything. Sometimes, these papers, yeah, I'm not seeing anything specific for our star. That sort of sucks. Oh, well, it should be in this list. Yeah, it should be in this list. Come on. What is it? APS? APS? There's Theta Apus. There's NQ Apus. There's OO Apus. There's Delta 1. Yay! Woohoo! Delta 1 Apus. Okay, what is it saying here? So this is the Hipparchus number. Spectral type M53, V magnitude 4.68. pi. Oh, what is pi? I don't remember what pi is. I'm not sure. But look, they found three different variability periods for this star: 68 days, 94.9 days, and 101.7 days. Now, one of these, I would think, would be. Okay, well, let's see if there's any other references to delta. Oh, that looks like that's it. So just some basic data. I'm really interested in knowing what pi is. Let's see. Let's look at the beginning of the table. No, it's not going to do it. Maybe it's at the end. No, it's not at the end. I'm not quite sure what pi is. It's some kind of milliarcseconds, but I'm not quite sure what that number means. And m sub k, that would be, I guess, the k magnitude. I guess this would be the k absolute magnitude. Let's do this. What is this? Table 3. You're seeing science in action, at least scientific research in action. 14 stars have no determined periods, although we retain them in table 3 to document their MK. Period analysis. Periods 300 days. All right, they're just not going to tell us, at least not in my quick. Presented in table 3 with stars ordered by ascending Hipparchus catalog. Yeah, it's just not gonna. It's not going to tell us much. Anyway, that is our object of the day, Delta 1 Apus, in the constellation of Apus, and it looks like it's at least a an M star with pretty complicated variability, and it is what I would call a visual binary star, because there's also delta 2 right next door. Let's just take a quick look at the sort of the area, delta 1 and delta 2, just for fun. Zoom out here a little bit. Pretty bright stars, as you can see. Yeah, very cool. Very cool. Pretty red, as you can see. Those are pretty red stars, as expected. All right. Well, I think that is going to be that for today. So let's get out of here. I'm going to stop sharing my screen. I'm going to come back over here and wish you all a great evening, a great day. We'll be back again tomorrow, 2 hours UTC, a little less than 23 hours from now, and we'll do it again. We'll gather together again, and talk more astronomical stuff. Could be anything. If you guys have any ideas at all, any kinds of topics, bring them up. Send me an email, cosmiclettuce@gmail.com. You can join my Discord server. There's a link to it down below. yeah, let's keep the conversation going. This is a lot of fun, and I don't see any point in stopping it at this point at all, because it's just too much fun and it's too easy. It's way too easy, way too easy. So, all right, I am going to get out of here. I, uh, yeah, I'll look out. I'll look out. I don't know about up. I don't know really which way up is, but I definitely know which way out is and which way in is. So if it's okay, I'm going to keep looking out, and you know, not sort of you know ducking. I'm going to be looking out, out that way. Um, all right, well, cool. I'm going to get out of here for now, and hope everybody has, as I said, a great evening, a great day. Share this around. You know, I this live stream can I think only get better and better and better. And so, any kinds of recommendations you have in terms of, things that I should do, things I shouldn't do, um, you know, I'm just going to, do my thing otherwise. And, if that's okay, then that's exactly what I'm going to do. So, because as I said, you know, for me, this is easy. It's fun. It's something that I'm doing anyway. So it's awesome, to share um, um, with you folks all of this, and just think astronomy for a little while each day. I think it's fun. I think it's cool, um, and yeah, I think it can only get better and better and better. So all right, I'm gonna get out of here. Yes, the mothership is calling. So I've got to get off of this planet. It's just, I can't stand it anymore. All right. So I'm going to get out of here. I will see you on the spin. Don't get dizzy. Don't get dizzy. It's a smooth ride. And you've got to be used to it by now, right? You got to be used to it. But don't fall off. Hold on to your hats. And I will see you again. Um, just just our motion going around the planet once, and going around the sun in one day, and then our sun going around the center of the galaxy in one day covers about 20 million kilometers. So I will see you out there 20 million in about 23 hours. All right, Pierce, peace, cheers, take care, and I will see you on the spin. Bye.